All right, this is the last day of learning for Module 2, and we're going to be looking at rotational symmetry as well as, I guess you could call it reflectional symmetry. So let's go ahead and try the do now for today. You might want to pause the video, and then here's your homework from last night. You can check your answers to that as well. So it says a dilation with center 0, 0. And a scale factor of 2.5 maps AB onto 10, comma, negative, that is 25. Okay? What are the values of A and B? Well, if you multiply A times 2.5 and it gives you 10, you're going to work backwards to figure out what A is. So you're going to divide it by 2.5. So if you take 10 and divide it by 2.5, then the same thing you're going to do is take 25 and divide it by 2.5. So 10 divided by 2.5 is 4. So the value of A is 4. And negative 25 divided by 2.5 is 10. Negative 10. So the original coordinates would be 4, negative 10. All right, if you look at the answers to your homework from last night, you should see that here are the answers for 1 through 6, 4 through 6. Here's the rest of it. So if you have not finished checking all of your answers, I would go ahead and pause the video at this time and ask any questions. If there are any of these that you did not know how to do, remember your test is coming up. So if there are any of these that you do not know how to do, ask now and we can come around and help you. All right. So today, like I said, we're talking about rotational symmetry. So some things that have rotational symmetry are a Ferris wheel, a clock, the earth, people that do spins on their skateboards or snowboards, right? And then if we're talking about lines of symmetry, then we're talking about reflectional symmetry. And so you'll notice that a butterfly has symmetry, you have symmetry, the British flag has symmetry, so on and so forth. So most objects in nature have some kind of symmetry. So the first thing you're going to be tasked to do today is to look at some figures and try to draw a line of symmetry. Now, line of symmetry is a place where you can take the figure and fold it, and it'll fold onto itself. So if I draw a line of symmetry here, picture this coming up, and it will not fold on itself. So therefore, a horizontal line is not a line of symmetry. However, if I draw a line like this point, if I folded it, would land here, and this point, if I folded it, would land here, and therefore it would fold upon itself. This shape here, I'm going to have to draw a diagonal line here. And if I then fold this up, it will land on itself. And here, there's many lines that you could draw, but I'll just draw the one down the middle here. And again, if you folded it, but you could also see that if I drew it here, it would fold. If I drew a diagonal, it would also fold. So some have more than others. Today, you are going to be tasked with finding at least one line of symmetry in several shapes. So that's a line of symmetry. It's essentially where you can cut a shape in half. Now, if I were you, I would take my paper and test it. You could use a piece of patty paper, trace the figure, fold it, and see if it folds on itself. Or you can just actually take your assignment and fold it and see where it folds on itself if you're struggling. All right, so that's a line of symmetry. Now, rotational symmetry is a little different. So rotational symmetry is if a figure can be turned 180 degrees or less and it looks exactly the same, then it has rotational symmetry. So what you're going to do is you're going to try to draw a point exactly in the center of your figure. And for me, I'm going to trace right here on the whiteboard. But for you, you will have patty paper that you can trace with. And then, if this works, I should be able to rotate like this, and it should land on itself every time. So how many times can I rotate it and it lands on itself? And again, I'd have to slide it a little bit, but it should land on itself every time. And so what you can do is you can count how many points it has. So this would have 1, 2, 3, 4, 5, which means I can rotate it 5 times, and it will land on itself. All right, let's look at the shape here. So again, you're going to draw kind of a dot in the middle. That's your point to rotate around. Trace the figure the best you can using your patty paper. Hold your pencil tip on that point, and then try to rotate. And if you rotate it 90 degrees, obviously it's not going to land on itself. This is 180 degrees. Again, it does not land on itself. And so this one we would say does not have rotational symmetry because you have to rotate it 360 degrees for it to land on itself. So we would say no. The third shape, once again, I'm going to put my point in the middle of the shape, trace around. With your patty paper, I would put my pencil tip there and, oops, I'm rotating the wrong one. And again, this does land, I just have to slide it. So you should see that it would rotate there. That's 1. There's 2. And then back up on itself. Oops. There's 3. So this would be 3 times. Let's go ahead and try number 4. Put your point in the middle. You can see, nope, that's not going to land. Nope. So this one does not have rotational symmetry. This one's interesting. Let's see if the S has rotational symmetry. Look at that. It does, because it's 180 degrees or less. That's interesting. And what about this B? No, the B does not. But the number 8 would, right? And then SOS, make a prediction. What do you think? Sure enough, it does. Wow, that's pretty cool. So that's rotational symmetry, and you're going to look at some shapes today and determine whether or not they have rotational symmetry. Remember, 180 degrees or less. So all of the ones except for numbers 2, 6, and 4 would have rotational symmetry because it's 180 degrees or less. Now we're going to determine the degree of rotational symmetry. All right, for this, you first test to see if, in fact, it does have rotational symmetry. So if I'm looking at this here, it does, it's going to rotate 1, 2, 3, 4, 5, 6, 7, 8 times, okay? So this has 8 times rotational symmetry. You can also count the points. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And that'll tell you, yes, in fact, this is going to be able to rotate it 8 times. Now, rotation, a full turn is 360 degrees. So to find out the degree of rotational symmetry, you take 360 degrees and divide it by 8. And you should get 45. So each time you rotate this shape, 1 turn, it's 45 degrees. So if I rotated from here to here, my degree of rotation would be 45, another 45, and another 45. So 45 times 3, 135 degrees. So this whole part here is 135 degree rotation. Let's look and see if this one has rotational symmetry. And if it does, how many times you can turn it. There's 90. Okay, so this can only be turned once. So since it can only be turned once, it's exactly 180 degrees. So last shape. Again, this is not in your packet yet. You're just learning how to do it. So there's 90. No, this does not even have rotational symmetry. So this one doesn't even have rotational symmetry, so we can't determine the degrees. All right, let's look at some more. So it says, what degrees of rotation will rotate the triangle or the shapes onto itself? So again, what we discovered is if I turn this, I can turn it 1, 2, 3 times. So I'm going to take the total, which is 360, and divide it by 3. So each turn here is 120 degrees. Now let's look at this. This is, I believe, a pentagon, right? So we've got 1, 2, 3, 4, 5. So I'm going to know how many degrees is each turn if I just turn it one time. So I'm going to take 360 divided by 5. That's 752 degrees. So each one is 72 degrees. So again, if I went from, say I started here, at this point here, and I wanted to rotate all the way around to here, it would be 72, 72, and 72. So 72 times 3, 216 degrees. And let's see this last shape. Let's see what we can call it. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. We did this one already. 360 divided by 8 is 45 degrees. So each turn upon the center is 45 degrees. Here's an example of what a question might look like. A clockwise rotation of 60 degrees maps P onto R. I'm sorry, maps R onto S. This right here is going to be 60 degrees. How do I know? So there's 1, 2, 3, 4, 5, 6. 360 divided by 6 is 60 degrees. So you are onto S. A counterclockwise rotation, oh, and it was clockwise, so we have a counterclockwise rotation of 60 degrees about, well, we're always rotating about the center. So it'd be about P. Okay, so now we're going clockwise again. A rotation of 120, so how many turns is that going to be? That's going to be 2 turns. About Q, this should say P, sorry. About P maps R, so we're going to rotate twice clockwise. So here's 1, 2. It's going to map it onto T. And then a counterclockwise rotation of 180 degrees about P moves V onto, well, 180 is going to be 3 turns. So V, go 1, 2, 3. It's going to go to R. All right. Another type of question, you might be given a shape like this, and it says, identify the rotation, name the image of E for a 72-degree counterclockwise about X. So E is going 72 degrees. So first we have to notice that this is a 1, 2, 4, 5. So 360 divided by 5 is 72. And we're doing a 72-degree counterclockwise. So that would be up to here. So E would map onto. Okay, so what you'll notice is it goes on to E. All right, so now what you want to do is go to Canvas, and you want to see what your assignment is. So go to Canvas, check the assignment. You're going to be completing pages 18 and 19. And then we're going to start studying for the test. So page 18 through 19.